8 types of car suspensions. Double wishbone suspension. The double wishbone suspension also has an independent design, so the turning angle and suspension movement will not affect the geometry angle, because the angle will remain constant. The double wishbone suspension has drawbacks due to the fairly large space it requires. On top of that, when you want to replace a shock breaker or shock absorber, the disassembly process takes a long time. This suspension is fairly easy to get damaged in its parts, such as broken ball joint at the bottom or top, long tie rod, and end tear rod. To avoid various damage to the car, you can do sporing regularly. Multi-link suspension. Multi-link is a suspension developed by double wishbone and multi-link into a suspension that has a fairly complicated construction design because it has separate parts that are held together by joints. This suspension also has component ends that pivot on 2 sides of the arm. Construction is made by manipulating the direction of the force that will be received by the wheel. Multi-link is a type of suspension that has quality grip, and with this suspension, controlling the car becomes easier. The multi-link suspension also has many variations. If this suspension is damaged, then the replacement process takes a long time and the spare parts are still rare, so the price is relatively more expensive than other suspensions. Rigid axle suspension. Rigid axle suspension is usually placed at the rear of the car. The main feature of this suspension is its wheels on the rear left and right. The 2 wheels are connected into one axle, which is commonly referred to as the axle. The rigid axle suspension has 2 models at once, namely the axle rigid model, which is equipped with leaf springs, and the axle rigid model, which is equipped with a coil spring or often referred to as spring. This suspension has fairly good quality and can be applied in various types of cars. It is fairly simple because it can work with just one solid piece and is equipped with 2 springs. The axle rigid is also considered a strong suspension, so it can support large loads stably, making it suitable for various types of large cars. Suspension can help dampen the vibrations or shocks that occur when you are on a road that is uneven or tends to be bumpy. With a good quality suspension car, you can stay seated without any disruption. The suspension is not only useful to help reduce vibrations when the car is driving, but can make handling safer and let the car can run stably on the road. With its very significant use, of course, the suspension is a must-have component in a car and it must get extra care. Now there are many types of cars around the world, and this makes a variety of suspension types available. Even the use of suspensions in each car brand is always different due to a large number of quality suspensions. Differentiating the type of suspension in each car brand is certainly a way to balance the type of car. At least several types of suspension are widely popular and used in cars produced nowadays. MacPherson suspension. MacPherson is a suspension whose name is taken from its inventor, Earl MacPherson. Lots of cars around the world use MacPherson suspension. Many automotive manufacturers like this suspension because it has an affordable price and also has fairly simple components. The MacPherson suspension has an upright shape and is supported by shock absorbers, which are used as the center point of the corner caster in the car. This suspension is also very easy to obtain because it's distributed widely. The disadvantage of MacPherson suspension is that it is less able to receive loads and the tilt angle always changes when the car is turned or turns. This makes the tires less able to grip the road asphalt properly. Double wishbone suspension. Double wishbone is a type of suspension that has 2 arms that support the suspension system, namely the upper and lower arms. With this suspension, the car can run stably. Independent suspension. Independent suspension is a specially designed suspension because the right and left wheels at the rear are not connected directly but instead by axle joints. If the rear wheel steps on a hole, of course, the car will not rock, and this is because only the left suspension moves. Independent suspension is indeed widely used in luxury cars. The independent suspension has a more complex construction and the axle movements are mutually independent. This suspension is also equipped with 2 flexible joints. This type of suspension is still fairly expensive, so its use is mostly in luxurious cars. Rigid suspension. Leaf spring. Rigid Leaf spring is one type of suspension that is widely applied in cars circulating in Indonesia and is mostly used in commercial type cars or old type cars. This suspension is usually used at the rear of the car because this suspension is stiff. This suspension has a fairly simple construction. This type of suspension usually consists of an axle housing that is intentionally tied using a U-bolt already attached to the frame. Cars that use this suspension usually have a fairly high level of resistance. Trailing arms A beam axle, rigid axle, or solid axle is a dependent suspension design in which a set of wheels is connected laterally by a single beam or shaft. Beam axles were once commonly used at the rear wheels of a vehicle, but historically they have also been used as front axles in four-wheel drive vehicles. In most automobiles, beam axles have been replaced with front and rear independent suspensions. With a beam axle, the camber angle between the wheels is the same no matter where it is in the travel of the suspension. A beam axle's fore and aft location is constrained by either trailing arms, semi-trailing arms, radius rods, or leaf springs. The lateral location can be constrained by a panhard rod, a Scott-Russell linkage or a Watts linkage, or some other arrangement, most commonly by the leaf springs. Shock absorbers and either leaf springs, coil springs, or airbags are used to control vertical movement. The twist beam rear suspension is a similar suspension design, however its beam axle is able to twist, thereby functioning as an anti-roll bar to control the roll motion of the body, and is considered to be a semi-independent suspension design. A live axle is a type of beam axle in which the shaft, or commonly, shafts connected to move as a single unit, also transmits power to the wheels. A beam axle that does not also transmit power is sometimes called a dead axle. While typically used in vehicles with Hotchkiss drive, this suspension system can also be used with other types of power transmission. Advantages: a beam axle is typically simple in design, rugged, and inexpensive to manufacture. Only one universal joint or constant velocity joint is needed at each steered and driven drive wheel, and none are needed at non-steered wheels. This reduces maintenance requirements and manufacturing costs compared to independent suspensions, which typically require two such joints at each driven wheel. A beam axle is space efficient, an important advantage for off-road applications, as it provides better vehicle articulation and durability in a high-load environment. Camber angle is rigidly fixed by axle geometry. For a live axle, toe is typically fixed as well. As the vehicle's body rolls during hard cornering, the unchanging camber yields predictable handling, at least on smooth surfaces. Wheel alignment is simplified. Traction, braking, and tire wear characteristics do not change as the suspension is compressed. These are great benefits in a vehicle that carries heavy loads, and together with the beam axle's characteristic strength, this has resulted in front and rear beam axles being nearly universal in buses and heavy-duty trucks. Most light and medium-duty pickup trucks, SUVs, and vans also use a beam axle, at least in the rear. Disadvantages: a beam axle does not allow each wheel to move independently in response to uneven surfaces, and handling is typically worse than more sophisticated suspension designs. In turns, the outside wheel is often subjected to adverse camber angles when the inside wheel hits a bump, which can suddenly reduce cornering grip and destabilize the vehicle. Camber angle cannot change during body roll, and the geometric roll center of the suspension is always fixed at the physical axle midpoint, limiting suspension tuning options. Furthermore, the roll center moves in reaction to road irregularities. Toe is typically fixed at 0 for a live axle, and dynamic toe control is difficult to implement. The mass of the beam is part of the unsprung weight of the vehicle, hurting ride quality. The need for lateral location devices, such as a panhard rod or Watt's linkage, adds more unsprung weight and partially offsets the beam axle's advantages in simplicity, space efficiency, and cost. In a vehicle with conventional Hotchkiss drive, the entire axle may twist in its mounts in reaction to torque loads. During hard acceleration, this may reduce traction and induce wheel hop or sudden adverse toe changes. The bulky differential housing of a Hotchkiss live axle reduces ground clearance, hindering the vehicle's ability to ford deep mud, clear obstacles, and negotiate deeply rutted roads. The differential housing can only be raised by using larger wheels and tires, typically with a penalty in unsprung weight, braking effectiveness, and acquisition costs. Furthermore, vehicle modifications may be necessary for adequate fender or frame clearance. Front beam axle suspension is unusually sensitive to any lack of concentricity in the hub and wheel assembly, which can cause a side-to-side oscillation, shimmy, of the steering at certain speeds, typically 60 to 80 kilometers per hour, commonly referred to as death wobble within the 4x4 community. This is addressed on some vehicles with steering dampers, although removal and careful refitting of the front wheels often cures the problem.
Multi-link suspension. Multi-link suspension is one type of car suspension systems, with one or more longitudinal arms. In a broader definition, a multi-link suspension can be considered as a suspension system with 3 control links or more multi-links. As there is no single multi-link setting in the industry, every car make and model has its own design. Derived from a double wishbone suspension, the multi-link suspension has 3 or more lateral arms, plus 1 or more longitudinal arms. The arms do not have to be of the same length. In addition, they can be angled away from their natural orientation. For example, as shown here, the multi-link suspension is like a double wishbone suspension, but with the addition of a 5th control arm. Each arm usually has a ball joint or rubber bushes at each end. Some multi-links use wishbones with 2 bushings on one end. Some multi-links also use trailing arms. As a result, they respond to loads along the arm's length in compression and tension, but without bending. For a 3-link layout, it allows free vertical, longitudinal and rotational motion, or we call the triple axis freedom. For a 4-link layout, it allows free vertical and rotational motion, or the double axis freedom. For a 5-link suspension, it allows only single axis freedom, the free vertical motion. To better understand multi-link suspensions, let's consider the function of these arms and the 3 orthogonal planes, the top, rear and side view. The top view, the arm needs to control toe, steer and lateral compliance. This requires a pair of longitudinally separated arms. The rear view, the arm needs to control the camber, to control how the camber changes as the wheel rebounds or drops up and down. The side view, the arm must transmit traction and braking loads, as well as to control caster. This is usually done by a longitudinal arm. Solid axle multi-link suspension. A variation of the same concept is the solid axle multi-link system. The solid axle multi-link system offers similar benefits, but has several advantages over independent multi-link suspensions. It is much cheaper and easier to build, offers good mechanical durability, and excellent reliability, and has very similar advantages. The solid axle multi-link suspension uses the lower and upper arm to control back and forth movement and rotation. This rotation occurs during acceleration and braking. The advantage: multi-link suspension is considered to be the best independent system for production vehicles, as it offers the best compromise between space efficiency and handling, as well as comfort and handling. In addition, multi-link suspensions are a great solution for off-road driving, as they allow the vehicle to bend more. In the simplest form, the multi-link suspension is orthogonal, that it is possible to change one parameter at a time within the suspension, without affecting the entire assembly. This is a significant difference from double wishbones. For a double wishbone suspension, moving a hardpoint, or changing a bushing compliance affects more than one parameter. In addition, solid axle multi-links have the advantage of being significantly cheaper, and much easier to build than independent multi-links. The disadvantage: despite all the advantages, multi-link systems are expensive, and complex to design and manufacture. In addition, it is difficult to tune the multi-link geometry, without a complete 3D computer-aided design analysis. McPherson strut suspension. The McPherson strut is the most widely used front independent suspension system, that the wheels are allowed to move independently. A McPherson strut suspension combines two major functions: as a steering rod, as a suspension dampener. Basic McPherson strut design. Let's look at the major parts of a McPherson strut suspension. A single control arm connected to the bottom of the wheel hub. A shock spring combination protruding from the top. The McPherson strut combines the coil spring and shock absorber into an integrated unit. This gives a more compact and lighter suspension framework that can be used for front-wheel drive vehicles. A steering link connected to the wheel hub. A McPherson strut suspension may also include an anti-roll bar, attached by a ball-jointed rod, to the spring damper. The advantage: the simplicity of the McPherson strut suspension is its major advantage. The McPherson strut suspension effectively combines spring, strength and stability and low manufacturing cost. Without the need for a separate upper control arm, the McPherson strut requires less components to produce, which is cheaper to make, more lightweight, and smaller than other suspension systems. The reduced unsprung weight also allows the vehicle to accelerate at a faster speed. McPherson strut suspension is great for front-wheel drive, since the space it allows for the drive shaft. There is nothing in the center, so it can easily accommodate a drive shaft there. The disadvantage: the McPherson strut suspension has a lengthy vertical assembly, which would run into problems if needed to lower the vehicle. Thus it's not suitable for a race car or sports car, as these types of vehicles are often lowered closer to the ground. Due to the simplicity of the McPherson strut suspension, it is small camber changes with body roll. Because the strut is moving linearly, the wheel gains camber to a certain extent, and after that will start to lose camber. This could hamper a car's handling, and experience a lot of body roll and cornering. This makes the McPherson strut more inferior to other advanced suspension systems, such as the double wishbone suspension. Nevertheless, the McPherson strut suspension still remains a brilliant invention, which effectively combines spring, strength and stability and low manufacturing cost.
The McPherson strut is a type of an independent suspension system. It is the most widely used suspension system for front axles of passenger cars. Less frequently, the McPherson strut modification is used on the rear axle of a car. You can see the most common design of the McPherson strut. The strut is a distinguishing element of this suspension system. It functions as both a shock absorber and an upper control arm. It frequently, but not always, comes with a coil spring as well. As this suspension combines several functions, it features a straightforward design and can have just one control arm. The McPherson suspension system includes several components, such as rubber bushings, ball joints, upper strut mount with a strut bearing, anti-roll bar bushings, and anti-roll bar links. The ball joints of the lower control arms and the strut bearing of the upper strut mount work together to turn the wheels. This motion is made possible by the steering mechanism, which is linked via a tie rod with a steering knuckle. The lower control arm may have different designs, such as those that include several arms or use the anti-roll bar as one of its pivot points. The rear McPherson strut suspension often features 3 suspension arms. For pros and cons of this suspension system, watch our
The leaf spring suspension. Basic design of a leaf spring. The leaf spring is a basic form of suspension, which is made up of steel layers of different sizes, sandwiched on top of another. The steel is usually cut into rectangular sections, and then secured once with metal clamps. The leaf spring is fixed to the axle housing by a large U-shaped bolt. Rubber bushings are used on the front and rear to reduce the impact from the road. A damper is also fixed in a clamp to dissipate the stored energy from the spring. The end of the leaf spring is directly connected to the frame by a shackle. How the leaf spring works. Most leaf springs are made in an elliptical shape using spring steel, which has the properties of allowing it to bend when pressure is applied at both ends, and then return to its original position through a damping process. The elasticity of the spring steel makes the suspension flexible, which can provide comfort and control when the car is driving. For decades, the leaf spring has proven to be a viable suspension system. It is common for many cars to use leaf springs as a dependent rear suspension. The advantage. Compared to coil springs and shock absorbers, leaf springs are simple in design and have low production cost. Mono-leaf spring is the simplest design, using only one leaf of spring, also called a parabolic leaf spring, that tapers from the middle thickness to the edge, to properly distribute the vertical load. Due to the large number of metal layers put together, the leaf springs provide great support between the wheels, axles and chassis of the car. Because of their tight-knit structure, they can withstand the huge vertical loads imposed on them, which is why they are still used in heavy industries. The vertical load is also distributed along the leaf spring, instead of sharply distributed through small springs and shock absorbers, which may generate too much concentrated force that the suspension cannot handle. The disadvantage. The big downside of leaf setups is that they are not brilliant when it comes to adjusting the suspension. In racing and high-performance automotive applications, being able to manipulate the suspension settings for different driving conditions is essential, and this is much easier to achieve with coil spring and shock absorbers. The fact that the end of the leaf spring is connected to the chassis leaves little room to shorten or extend the leaves. Therefore, it is only possible to adjust the strength and flexibility of the material that makes up the leaf springs. The leaf setups also allow few directions of motion, and are only really designed for vertical movement, while the coil spring and damper combination can be manipulated over a wider range of motion. The leaf springs are firmly clamped together and bolted to the chassis, as there is almost no room for any other direction of movement. This can cause severe wear on the joints and connections that hold the setup together. Nowadays, the popularity of leaf springs has declined dramatically, but is still commonly used in heavy industry vehicles. Torsion beam suspension. Torsion beam suspensions, also known as twist beam suspensions, are commonly found on some entry-level or cheaper car models, due to their low manufacturing costs. A torsion beam suspension bases on its design from a trailing arm suspension. Trailing arm suspension uses a trailing arm, which extends forward to a pivot on the car body. The upper part of the trailing arm supports the coil spring. Trailing arm suspension only allows the wheel to move up and down on road bumps. The design does not accommodate any lateral movement, or camber change relative to the car body. When the vehicle rolls into a corner, the trailing arm rolls by the same amount as the car body, changing the camber angle relative to the road surface. The arm is rigidly attached to the wheel at the other end, thus shock and noise can inevitably be transmitted to the car body, especially during cornering or driving on bumpy roads. Torsion beam suspension improves the design by joining the two trailing arms together by a cross member. The cross member itself acts as an anti-roll bar. The two wheels are attached to the ends of the beam and twist slightly under load. When a wheel hits a bump and goes up, the beam will be deflected, and transfer part of the load into the other wheel. It will produce a torque along the beam to force the other side to go up as well. The beam normally has a relatively low torsional stiffness and high bending stiffness. When the wheel experiences a vertical force, the wheel is going to turn, as the pivot is in the front. The relatively high bending stiffness will help to resist any vertical forces turned into moments on the wheel. The beam will still be able to deflect on a single wheel bump, due to the low torsional stiffness. A torsion beam suspension provides the wheels a certain degree of independence, but not fully independent, as they are still linked by the beam. It also differentiates from a stiff solid axle suspension. In a torsion beam suspension, the coil spring is mounted in combination with a shock absorber, to reduce the impact from the road. Compared to other types of suspensions, a twist beam suspension is simple in design and is cheaper to make. The beam itself acts as an anti-roll bar, that simplifies things at the rear. However, it doesn't allow for much wheel adjustment by engineers. It also needs a lot of reinforcement, to mitigate the fatigue at the welding points. As mentioned before, the torsion beam suspension is commonly referred to as semi-independent, and the two wheels can move relative to each other, but their movements are somewhat interrelated, rather than a full independent rear suspension. Torsion beam suspensions typically can be found in smaller and cheaper cars, as it is a good compromise between stability and cost. This suspension is widely used in a variety of compact front-wheel drive vehicles, and is mostly prevalent in European superminis.
£4,000. The V-Ride rear suspension system from FCCC incorporates revolutionary design and engineering already proven in heavy-duty applications. It offers tremendous benefits to the luxury motorhome experience, and it's a great selling point for potential buyers. V-Ride derives its name from the unique V-Rod design of the upper control arms. This V-Rod connection helps to dissipate suspension forces through the crossmember and frame rails, reducing stress throughout the rest of the suspension system for greater durability and longevity. The transverse beam of the V-Ride suspension is directly integrated with the trailing arm to form a single-piece U-shaped assembly. This unified design eliminates bushings connections found in traditional rear suspensions, providing superior rigidity. The integrated U construction and V-Rod control arms combine for less sway and a more stable ride. This is particularly noticeable to motorhome owners during curves in the road or when traveling over uneven campground roads. As a motorhome travels around a curve, its natural tendency is to lean and want to drift outward. When compared to a traditional system, V-Ride's revolutionary design maintains superior roll stability and more predictable handling. So motorhome owners have a consistent, confident driving experience in all road conditions, especially in the case of sudden road maneuvers. Drivers can also count on V-Ride for large volumetric air springs and premium Sachs shocks that are exclusive to FCCC chassis and deliver the smoothest ride available in a motorhome. In addition to superior roll stability and ride quality, V-Ride is the first ever single-axle RV suspension rated at 24,000 pounds. This gives you more towing capacity, more gear, and more luxury options than any other single-axle rear suspension in the motorhome industry. When it comes to the premium motorhome experience, V-Ride is a game changer. It delivers a more consistent, confident ride, and it's the only single-axle rear RV suspension rated at 24,000 pounds. It's luxury without limit.
Double wishbone suspension. The basic design. Double wishbone suspension is an independent suspension system. It allows each wheel to act independently from the others. This is accomplished by two wishbone-shaped arms, also called double A arms, that are located between the steering knuckle and the chassis. The upper and lower control arms have ball joints at both ends, to enable movement in all directions. Each wishbone or arm has two attachment points on the chassis, and one joint at the steering knuckle. Vertical motion is controlled via the coil spring and shock absorber mounted on the wishbones. The spring and damper could be attached to the upper control arms, and to the chassis. A more popular configuration is attached to the lower of the two A arms, as the system is much more compact. The advantage. The double wishbone suspension provides the driver with a smooth driving experience, especially on bumpy roads. As a more complex design, the double wishbone allows for better control over camber and body roll. What is camber? Camber is a measure of the tire's centerline relative to the road surface. It is measured in degrees, and has a great influence on the driving dynamics of the car. Negative camber, the top of the tire tucks inwards. Positive camber, the base of the tire tucks inwards. Effective camber control improves handling by keeping better contact of the tire with road, while the car rolls. It ensures that the tire's contact surface is evenly loaded. Traditional double wishbone suspension is made up of two parallel control arms of equal length. The advantage of this is that, as the tire has a positive or negative vertical motion, the tire travels in a straight line, and the camber angle stays the same. In principle, the double wishbone suspension always keeps the tire perpendicular to the road surface, regardless of the wheel movement. This helps to ensure good handling. The disadvantage is when the car goes around a corner, that camber angle changes as the car body rolls. Let's look at the camber when the car goes around a corner. In this case, the car is going around a right corner, and the car body is going to roll to the left. For a double wishbone suspension with equal length control arms, the car will have slight positive camber on the outside tire, and negative camber on the inner tire. This is not a desirable design, as the outer tire is taking most of the load, while the inner tire is taking less load. To solve this problem, the double wishbone suspension uses a shorter upper control arm, that the tire will have induced negative camber during a vertical travel. This is beneficial when the car goes around the corner. Due to the shorter upper control arms, the car will have slight negative camber on the outside, so the outer tire goes flat with the road surface. This is where the car wants to maintain the maximum amount of contact. The inner tire will have a slight positive camber. It is pressing flat against the road. The more a double wishbone suspension is compressed, the more negative camber is gained, due to the use of unequal length control arms. As the car is cornering and starts to roll, a double wishbone suspension system ensures better contact of the tires with the road. The disadvantage: a double wishbone suspension has more components, and therefore it is more expensive to design, manufacture, and maintain than other suspensions, such as the McPherson strut suspension. In addition, due to the large number of parts, a double wishbone suspension system is heavier, and requires more space than other suspension systems. The double wishbone suspension can be used on the front and rear wheels. It is independent, and above all it has almost perfect camber control. Nowadays, the double wishbone suspension has been the first choice for many racing and sports cars.
In automobiles, a double wishbone suspension is an independent suspension design using two occasionally parallel wishbone-shaped arms to locate the wheel. Each wishbone or arm has two mounting points to the chassis and one joint at the knuckle. The shock absorber and coil spring mount to the wishbones to control vertical movement. Double wishbone designs allow the engineer to carefully control the motion of the wheel throughout suspension travel, controlling such parameters as camber angle, caster angle, toe pattern, roll center height, scrub radius, scuff, and more. The double wishbone suspension can also be referred to as double A-arms, though the arms themselves can be A-shaped, L-shaped, or even a single bar linkage. A single wishbone or A-arm can also be used in various other suspension types, such as variations of the McPherson strut. The upper arm is usually shorter to induce negative camber, as the suspension jounces, rises, and often this arrangement is titled an SLA, or short long arm suspension. When the vehicle is in a turn, body roll results in positive camber gain on the lightly loaded inside wheel, while the heavily loaded outer wheel gains negative camber. Between the outboard end of the arms is a knuckle. The knuckle contains a kingpin for horizontal radial movement in older designs and rubber or trunnion bushings for vertical hinged movement. In newer designs, a ball joint at each end allow for all movement. Attached to the knuckle at its center is a bearing hub, or in many older designs, a spindle to which the wheel bearings are mounted. To resist fore-aft loads such as acceleration and braking, the arms require two bushings or ball joints at the body. Double wishbone suspension in action as on display at the Toyota Museum in Nagoya, Japan. At the knuckle end, single ball joints are typically used, in which case the steering loads have to be taken via a steering arm, and the wishbones look A or L-shaped. An L-shaped arm is generally preferred on passenger vehicles because it allows a better compromise of handling and comfort to be tuned in. The bushing in line with the wheel can be kept relatively stiff to effectively handle cornering loads, while the offline joint can be softer to allow the wheel to recess under fore-aft impact loads. For a rear suspension, a pair of joints can be used at both ends of the arm, making them more H-shaped in plan view. Alternatively, a fixed-length drift shaft can perform the function of a wishbone as long as the shape of the other wishbone provides control of the upright. This arrangement has been successfully used in the Jaguar IRS. In elevation view, the suspension is a 4-bar link, and it is easy to work out the camber gain, C-camber angle, and other parameters for a given set of bushing or ball joint locations. The various bushings or ball joints do not have to be on horizontal axes parallel to the vehicle's center line. If they are set at an angle, then anti-dive and anti-squat geometry can be dialed in. In many racing cars, the springs and dampers are relocated inside the bodywork. The suspension uses a bell crank to transfer the forces at the knuckle end of the suspension to the internal spring and damper. This is then known as a push rod if bump travel pushes on the rod, and subsequently the rod must be joined to the bottom of the upright and angled upward. As the wheel rises, the push rod compresses the internal spring via a pivot or pivoting system. The opposite arrangement, a pull rod, will pull on the rod during bump travel, and the rod must be attached to the top of the upright, angled downward. Locating the spring and damper inboard increases the total mass of the suspension, but reduces the unsprung mass, and also allows the designer to make the suspension more aerodynamic. Advantages. The double wishbone suspension provides the engineer more design choices than some other types do. It is fairly easy to work out the effect of moving each joint, so the kinematics of the suspension can be tuned easily and wheel motion can be optimized. It is also easy to work out the loads that different parts will be subjected to, which allows more optimized lightweight parts to be designed. They also provide increasing negative camber gain all the way to full jounce travel, unlike the McPherson strut, which provides negative camber gain only at the beginning of jounce travel, and then reverses into positive camber gain at high jounce amounts. Disadvantages. Double wishbone suspensions are more complex, impose more difficult packaging constraints, and are thus often more expensive than other systems like a McPherson strut. Due to the increased number of components within the suspension setup, it takes much longer to service and is heavier than an equivalent McPherson design. At the other end of the scale, it offers less design choice than the more costly and complex multi-link suspension system. The double wishbone suspension was introduced in the 1930s. French carmaker Citroën began using it in their 1934 Rosalie and Traction Avant models. Packard Motor Car Company of Detroit, Michigan, used it on the Packard 120 from 1935 and advertised it as a safety feature. During that time, McPherson strut was still in the area of aviation technology and was derived from aircraft.
Forget about the solid axle. The Rex is an independent suspension system, front and rear, that will double your Jeep's wheel travel from 10 inches to 20. It will expand your ground clearance by 3 inches. It will make your ride more comfortable and smooth. It will make your Jeep much stronger and stable, on and off-road. The revolutionary patented differential system will let you enjoy all the advantages of the independent suspension without modifying or damaging the JK chassis. In fact, it's very fast and easy to install the Rex bolt-on kit on your JK.
Air suspension is a type of vehicle suspension powered by an electric or engine-driven air pump or compressor. This compressor pumps the air into a flexible bellows, usually made from textile-reinforced rubber. Unlike high-drop pneumatic suspension, which offers many similar features, air suspension does not use pressurized liquid, but air suspension is using pressurized air. The air pressure inflates the bellows and raises the chassis from the axle. Air suspension is used in place of conventional steel springs in heavy vehicle applications, such as buses and trucks, and in some passenger cars. It is widely used on semi-trailers and trains, primarily passenger trains. The purpose of air suspension is to provide a smooth, constant ride quality, but in some cases is used for sports suspension. Modern electronically controlled systems in automobiles and light trucks almost always feature self-leveling along with raising and lowering functions. Although traditionally called airbags or air bellows, the correct term is air spring. although these terms are also used to describe just the rubber bellows element with its end plates. Vehicles that have used air suspension include models from Maybach, Rolls-Royce, Lexus, Jeep, Ram, Cadillac, GM, Mercedes-Benz, Citroën, Porsche, Land Rover, Ssangyong, Audi, Subaru, Volkswagen, Lincoln, Ford, and Tesla, among others. Some Citroën vehicles feature hydroactive suspension, a computer-controlled version of their hydropneumatic system, which features sport and comfort modes, lowers the height of the car at high speeds, and continues to maintain ride height when the engine is not running. The air suspension designs from Lincoln, Land Rover, Ssangyong, Chrysler, Subaru, Audi, Volkswagen, Tesla, Porsche, and Lexus models feature height-adjustable suspension, suitable for making it easier to enter the vehicle, clear bumps, or clear rough terrain. The Lincoln Continental, Town Car, Navigator, and Mark VUI also featured an air suspension system, which offered a controlled but smooth ride. Jaguar and Porsche has taken this to the next level on their XJ and Panamera models, with a system that changes the spring rate and damping settings, among other changes, for their sports/track modes. The Mark VUI suspension settings were also linked to the memory seat system, meaning that the car would automatically adjust the suspension to individual drivers. The control system in the Mark VUI can lower the suspension by about 25 millimeters, 1 inch, at speeds exceeding about 100 kilometers/a 60 miles per hour for improved aerodynamic performance. One way automakers strive to improve gas mileage is by utilizing active suspension technology. Tesla Motors offers an included active air suspension on the Model S and Model X to lower or raise the vehicle for aerodynamics and increased range. In 2014, the new C217 S-Class Coupe introduced an update to Magic Body Control called Active Curve Tilting. This new system allows the vehicle to lean up to 2.5 degrees into a turn, similar to a tilting train. The leaning is intended to counter the effect of centrifugal force on the occupants and is available only on rear-wheel drive models. Over the last decade or so, air suspension has become popular in the custom automobile culture. Street rods, trucks, cars, and even motorcycles may have air springs. They are used in these applications to provide an adjustable suspension, which allows vehicles to sit extremely low, yet be able to rise to a level high enough to maneuver over obstacles and inconsistencies on paved surfaces. These systems generally employ small, electric or engine-driven air compressors, which sometimes fill an onboard air receiver tank, which stores compressed air for use in the future without delay. It is important that the tank is sized for the task and can be calculated using a specific formula involving the compressor output, standard atmospheric pressure, and compressed pressure. High-pressured industrial gas bottles, such as nitrogen or carbon dioxide tanks used to store shielding gases for welding, are sometimes used in more radical air suspension setups. Either of these reservoir systems may be fully adjustable, being able to adjust each wheel's air pressure individually. This allows the user to tilt the vehicle side to side, front to back, in some instances hit a 3-wheel, contort the vehicle so one wheel lifts up from the ground, or even hop the entire vehicle into the air. When a pressure reservoir is present, the flow of air or gas is commonly controlled with pneumatic solenoid valves. This allows the user to make adjustments by simply pressing a momentary contact electric button or switch. The installation and configuration of these systems varies for different makes and models, but the underlying principle remains the same. The metal spring, coil, or leaf is removed, and an airbag, also referred to as an air spring, is inserted or fabricated to fit in the place of the factory spring. When air pressure is supplied to the airbag, the suspension can be adjusted either up or down, lifted or lowered. For vehicles with leaf spring suspension, such as pickup trucks, the leaf spring is sometimes eliminated and replaced with a multiple bar linkage. These bars are typically in a trailing arm configuration, and the air spring may be situated vertically between a link bar or the axle housing and a point on the vehicle's frame. In other cases, the airbag is situated on the opposite side of the axle from the main link bars on an additional cantilever member. If the main linkage bars are oriented parallel to the longitudinal driving axis of the car, the axle housing may be constrained laterally with either a panhard rod or Watts linkage. In some cases, two of the link bars may be combined into a triangular shape, which effectively constrains the vehicle's axle laterally. Often, owners may desire to lower their vehicle to such an extent that they must cut away portions of the frame for more clearance. A reinforcement member, commonly referred to as a C-notch, is then bolted or welded to the vehicle frame in order to maintain structural integrity. Specifically on pickup trucks, this process is termed notching because a portion notch of the cargo bed may also be removed, along with the wheel wells, to provide maximum axle clearance. For some, it is desirable to have the vehicle so low that the frame rests on the ground when the airbags are fully deflated. Owners generally choose between having their cars tuck their wheels into the arches when their air suspension is fully lowered, or alternatively, they can choose to go for fitment, which in partnership with stretched tires sees the arch itself fit in between the tire and rim. Air suspension is also a common suspension upgrade for those who tow or haul heavy loads with their pickup truck, SUV, van, or car. Air springs, also called air helper springs, are placed on existing suspension components on the rear or front of the vehicle in order to increase the load capacity. One of the advantages of using air suspension as a load support enhancement is the air springs can be deflated when not towing or hauling, and therefore maintaining the factory ride quality. Common air suspension problems. Airbag or air strut failure is usually caused by wet rust, due to old age or moisture within the air system that damages it from the inside. Air ride suspension parts may fail because rubber dries out. Punctures to the airbag may be caused from debris on the road. With custom applications, improper installation may cause the airbags to rub against the vehicle's frame or other surrounding parts, damaging it. The overextension of an air spring, which is not sufficiently constrained by other suspension components, such as a shock absorber, may also lead to the premature failure of an air spring through the tearing of the flexible layers. Failure of an air spring may also result in complete immobilization of the vehicle, since the vehicle will rub against the ground or be too high to move. However, most modern automotive systems have overcome many of these problems. Airline failure is a failure of the tubing, which connects the airbags or struts to the rest of the air system, and is typically DOT-approved nylon air brake line. This usually occurs when the airlines, which must be routed to the airbags through the chassis of the vehicle, rub against a sharp edge of a chassis member or a moving suspension component, causing a hole to form. This mode of failure will typically take some time to occur after the initial installation of the system, as the integrity of a section of airline is compromised to the point of failure due to the rubbing and resultant abrasion of the material. An airline failure may also occur if a piece of road debris hits an airline and punctures or tears it, although this is unlikely to occur in normal road use. It does occur in harsh off-road conditions, but it's still not common if correctly installed. Air fitting failure usually occurs when they are first fitted or very rarely in use. Cheap, low-quality components tend to be very unreliable. Air fittings are used to connect components such as bags, valves, and solenoids to the airline that transfers the air. They are screwed into the component, and for the most part push-in or push-to-fit DOT line is then inserted into the fitting. Compressor failure is primarily due to leaking air springs or air struts. The compressor will burn out trying to maintain the correct air pressure in a leaking air system. Compressor burnout may also be caused by moisture from within the air system coming into contact with its electronic parts. This is far more likely to occur with low-specification compressors with insufficient duty cycle, which are often purchased due to low cost. For redundancy in the system, two compressors are often a better option. In dryer failure, the dryer, which functions to remove moisture from the air system, eventually becomes saturated and unable to perform that function. This causes moisture to build up in the system and can result in damaged air springs and slash or a burned-out compressor.
Discuss the different types of front-wheel independent suspensions. We know that independent suspension can be defined as a suspension arrangement in which no rigid beam axle is used and both wheels are separately connected to the carriage unit. Now, independent suspension used for front wheels is known as front-wheel independent suspension, whereas the independent suspension used for rear wheels is known as rear-wheel independent suspension. Now, front-wheel independent suspension is mainly of 5 types. double wishbone type, MacPherson strut type, vertical guide type, training link type, and swinging half-axle type. Let us discuss each in brief. Double wishbone type suspension. A typical double wishbone type suspension can be shown as: it consists of two suspension or control arms for each wheel, called the upper wishbone arm and lower wishbone arm. These arms are named wishbone because they take the shape of letter V or chicken wishbone. The open ends of both control arms are pivoted to the chassis frame, whereas the closed ends are connected to the stub axle with the help of a connecting arm and kingpin. The coil spring with the shock absorber is placed in between the lower wishbone and the frame member. Now when the wheel hits a bump, the control arms move up, thus compressing the coil spring. Since the shock absorber is also fitted with the spring, it damps the vibrations set up in the coil spring. The V-shape of the control arm helps in many ways. It keeps the wheels in correct position. It transmits the sprung weight to the spring. It resists the acceleration, braking, or cornering forces. Also, the upper control arm is kept shorter in length than the lower control arm. This is done to keep the wheel track constant while cornering, thereby providing less tire scrub. MacPherson strut type suspension. A typical MacPherson strut type suspension can be shown as: it consists of a single lower wishbone arm, which is hinged to the chassis of the automobile. The other end of this wishbone arm is attached to the strut through a joint. The strut containing the shock absorber and the spring is connected to the stub axle which carries the wheel. The upper end of this strut is fixed to the body structure through a flexible mounting. Due to this, a stronger body is required to absorb the full suspension load. Therefore, frameless chassis construction is preferred for this suspension. Here, the steering motion of the wheel is provided through the lower control arm. MacPherson strut suspension has many advantages, such as: it is very easy and cheap in construction and requires very less maintenance. It is lighter and simpler than double wishbone suspension, thus keeping the unsprung weight lower. It requires very less space and so is very useful in front-wheel driven automobiles where more room is required in the engine compartment. The vertical guide type suspension. A vertical guide type suspension can be shown as: it consists of an extended cross member to which the kingpin of the stub axle is attached at one end. The coil spring and the shock absorber are attached on this stub axle. The other end of the kingpin is fixed to an upper spacing bar. According to the up and down motion of the wheel, the kingpin is also allowed to move up and down, thus compressing or elongating the spring. The major disadvantage of this type of suspension is decreased stability of the automobile. Trailing link type suspension. A typical trailing link type suspension can be shown as: in this suspension, a horizontal torsion spring with shock absorber is attached to a trailing linkage, which is attached to the shaft that carries the wheel hub. The other end of the coil spring is attached to the frame side member. Now when the wheel moves up or down, it winds or unwinds the spring respectively. In some automobiles, torsion bar is also used in place of coil springs. The major disadvantage of this suspension is that the distance between the front and rear wheels during springing changes. Also, it requires very much space. Swinging half-axle type suspension. A typical swinging half-axle type suspension can be shown as: in this suspension, both wheels are mounted rigidly on the half-axles, which are pivoted on their ends to the chassis member at the center of the vehicle. The spring with the shock absorber is mounted on this half-axle. Now, when one wheel of the automobile experiences a rod shock, the axle with that wheel swings up or down without affecting the other wheel. The major disadvantage of this suspension is that due to up and down movement, the wheel doesn't remain perpendicular to road. Also, during cornering, the outer wheel with higher load tilts outwards, thus losing traction. Note that out of above 5 suspensions, double wishbone and MacPherson strut suspension are most commonly used. Now let us summarize the front wheel independent suspension as: